In the early 1900s, J. Thomson proposed that an atom was a uniform sphere of positively charged matter in which electrons were embedded. This model is sometimes called the plum pudding model. Electrons are embedded in a sphere of positive matter similar to raisins in plum pudding. In 1910, Ernest Rutherford, Hans Geiger, and Ernest Marsden carried out experiments in which very thin foils of metal were used as targets for alpha particles emitted from a radioactive source. Based on Thomson's model, Rutherford expected that the positively charged alpha particles should pass through the uniform sphere of positively charged matter with little or no deflection. Click on Actual Experimental Results to see what actually happens. Rutherford observed that the majority of alpha particles penetrated the foil either undeflected or with only a slight deflection. Every now and then, however, an alpha particle was scattered or deflected at a large angle. In some instances, an alpha particle actually bounced back in the direction from which it had come. This was a most surprising finding, for in Thomson's model, the positive charge of the atom was so diffuse, or spread out, that based on the results of his experiment, Rutherford postulated a nuclear atom. All of the positive charge and most of the mass of the atom is concentrated in a very small volume called the nucleus. Electrons occupy the remaining space of the atom. The radius of an atom is approximately 20,000 times larger than the radius of the nucleus. Most of the positively charged alpha particles pass straight through the diffuse electron clouds of the atoms. Some alpha particles pass close to the small positive nuclei and are deflected at large angles. A few particles score a direct hit on the nuclei and come almost straight back.